Airport planning has become a discipline that provides efficient answers for important urban centers. A new concept, airport cities, provides commercial aviation solutions while fostering business in air terminals with higher levels of service and consumption standards within the airports. Mega projects attract the top world's professionals along with the best research and latest technology in order to find the best solutions to each project. While this happens, millions of passengers all over the world live a very different situation. Both passengers and those who daily circulate near those small air terminals are exposed every day to uncomfortable, dangerous, and unsafe situations. None of these problems are correctly addressed because these small airports have low traffic or are badly located and therefore have a reduced economic scale. Corporación América has vast experience in planning, execution, and management of airports worldwide. In each project, it has optimized airport needs, taking advantage of and respecting the particular characteristics of each place. With its expertise, it has shown how projects can be made to adjust to different people and environments. Baltra, main entrance for the Galapagos Islands, one of the most important national parks of the world, declared World Natural Heritage Site by UNESCO. The islands face the difficulty of depending on tourism to survive, while they need to control this demand because of the high vulnerability of the environment. The best solution? A sustainable building. To achieve friendly and appropriate conditions for international passengers and local residents, the project for the new airport terminal is designed to limit environmental impacts, incorporating a series of complementary passive design and low-energy strategies. All this including LEED Golden Certification process. Cross-ventilation and natural air movement for cooling. The project locates the new building at a safe distance from the runway, but orientated to catch breezes and avoid direct sun and complies with international safety requirements of National Park Authority. The terminal is located at an angle of 45 degrees to the runway. This orientation is optimum for solar protection and catches the prevailing breeze. The distance from the taxiways and predominant wind direction also ensure that the fumes from the jet engines of the moving and parked aircraft do not enter the building. Total protection from direct solar radiation in all indoor spaces. The building is used exclusively in the morning between 7:30 and 13 hours, when air temperatures are lower. Use of buried air ducts for cooling in critical spaces. Where additional cooling is required, buried air ducts with forced ventilation are used to achieve moderate low-energy cooling without using artificial refrigeration. Reflected and diffused natural lighting in all public and office spaces. The daylight design was developed using model studies in an artificial sky and numerical simulations covering all the main internal spaces using the program Radiance. Two systems of south-facing clerestories are located in the check-in hall and in the center of the building, working as a lighting entrance and warm air circulation. Energy. The airport terminal incorporates two renewable energy systems. Photovoltaic panels located in the sector of the low-pitched roof without any overshading. A series of solar hot water installations for the bars, restaurants, and showers. The PV system provides about 25% of the building demand and 12% of the total airport demand. Water. The island has no water supply. Rainfall is very limited. The water is therefore supplied by a desalination plant and pumped to storage tanks in the airport. Gray water is treated and recycled to reduce the demand for desalination. The simple roof design has a direct slope to downpipes on the perimeter of the building, where rainwater is collected and filtered before use in flush toilets. Special installations are used to reduce water use, with waterless urinals, low-flow shower heads, and press-button taps. Avoidance of mechanical cooling in a site at sea level on the equator. Thermal comfort problems can be solved by changing a combination of factors: low ceiling heights, total lack of thermal insulation, insufficient space, and dark external roof surface. Also, insufficient natural ventilation. The prevailing wind comes from the southeast with little variation, and the runway is oriented accordingly. The average monthly wind speed varies between 12 and 18 kilometers per hour, with higher velocities at midday. Bioclimatic strategies are incorporated in the architectural design. Solar protection, avoiding direct solar penetration during operational hours. Reflection, white roof. opaque west and east walls related to the terminal orientation. Patio protection, protecting inner spaces of solar heat even during Senate hours. Thermal insulation, 5 centimeters incorporated to roof and opaque walls, avoids temperature elevation. Cross ventilation, orientation of the building catches wind all across the building. Thermal inertia, election of materials. Stratification, height of ceilings lets ascension of warm air. Stack effect, light opening act as air ducts. Natural extract, suction effect of different air temperatures. Extract ventilation. Toilets and cleaning areas do not need mechanical air extraction due to the building orientation in respect to the prevailing wind. Landscape. The majority of the international tourists arrive to see the unique flora and fauna and special ecological conditions found in the islands. Therefore, the building offers a special experience with conditions that aim to reflect the local climate rather than provide an artificially controlled environment typically found in conventional airport terminals. The views to the open landscape, the patios with local plants, and the local stone walls all combine to support this first and last impression of the islands. The treatment of the outdoor spaces around the airport is therefore intended to mark a transition from the building to the natural landscape. The landscape design does not require any irrigation or use of drinking water. The airport of Baltra is located over 1,000 kilometers from the coast, and all flights are internal, coming from Quito or Guayaquil on the coast of Ecuador. Therefore, the airport does not have customs facilities, but strict control is necessary to avoid the smuggling of plants and animals to and from the islands, and additional measures are taken to avoid the insertion of insects, especially mosquitoes. Capacity. The present capacity of the airport is 5 flights a day, with an average capacity of 100 passengers, totaling 1,000 passengers passing through the terminal daily, 500 entering and 500 leaving. Most are international tourists, but between 25 and 30% are local residents. The new airport is designed to handle up to 10 flights a day, doubling the present capacity, though no further expansion is envisaged in order to control the environmental impact of the tourist industry. Sustainable construction, green building, life preservation, natural future. Lightweight, easy and fast to construct and deconstruct and remove or change. All public spaces and private offices have outdoor views. The structure is totally independent of the masonry, modular and facilitating eventual deconstruction and recycling. Conclusions. The new airport terminal responds to a special site with strict environmental, logistic, legal, and economic limitations. The lack of water and conventional energy supplies, the distance from the mainland, the control of imported materials, and the need to reduce environmental impacts all contribute to the development of a design that achieves thermal and luminous comfort with natural conditioning within strict cost limitations. The companies related to the project have a strong commitment to sustainable enterprises, understanding that the future needs some austerity and comfort design. We are looking forward to this challenge because we care about future generations. Thank you.